Let's go ahead and do some practice problems for formal charges. And formal charges, as a quick refresh, is that atoms in a molecule can be assembled in different ways. And these formal charges are going to be calculated to identify the most stable or most likely structure. Now remember, for informal charges, you need to make sure that each atom will be a zero for a neutral molecule. And once you sum up those formal charges, you should end up with an overall charge for the polyatomic ions. So we're talking about polyatomic ions, we're really talking about those formal charges. So how to tell which structure is more likely to form a formal charge? Most likely the overall Lewis dot structure is going to have a formal charge of 0. If there's any sort of negative formal charges, we want to make sure that those more electronegative elements are inside that structure for that negative charge. The quick and easiest way to remember formal charges is to take the number of valence electrons assigned minus the number of electrons assigned in the atom in the structure. And that should tell you how many electrons are assigned to each one. And we're going to add how many lone pairs you have around the atom plus the number of bonding electrons divided by 2, because each covalent bond is sharing 2 electrons. Alright, so let's go ahead and get started. So the question here is, which one is the most likely structure? ClNCl or NClClCl. And in both cases, they both have electronegative values of 3.0 for that. So big question usually comes up is, which one do we put in the middle? Now, in order to determine that, we need to figure out what the formal charge is for each of the elements. And what you're going to have to do here is go ahead and put these on so that you can assign the valence electrons. Alright, so the first thing you're going to do is put the valence electrons for each one and how many electrons are assigned, and then subtract that difference. So for nitrogen and chlorine, we already know that it's going to be 7 across. So chlorine has 7, 7, 7, nitrogen has a 5. And now we have to figure out how many electrons are in each one. So for nitrogen here, we have 1, 2, 3, 4, 5, 6, 7, and then 2, 4, 6, 7. And chlorine, we have those. So if you take a look at chlorine, we have 7 as well, 2, 4, 6, and 7. There's 1 electron here, 2, 4, 6, and 7, and so on. But there's one of them that actually has a 5. I think it's this one right here in the middle. Sorry, 1, 2, 3, 4, 5. So you subtract that, you get a formal charge of -2, 0, 0, and 2. And the reason why is because that nitrogen here with that -2 doesn't really quite make sense. Nitrogen is not as electronegative as chlorine, and you're not getting that 0 overall charge, so this most likely will not work. Even though if you actually add up the charges, you should get 0, but again, we don't really like that nitrogen in there. So let's try the other situation. Now where we have nitrogen and chlorine, and so go ahead and assign them one more time. So we're going to put 7, 7, 7, and 5 across. And the number of electrons assigned in this case is, again, taking a look at each one. But here, because we moved the nitrogen to the middle, you can actually count it a little differently. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, and 7. So 7, 7, and 5. 7 for the chlorines, 5 for the nitrogens. And this one makes a little bit more sense. All of them now have 0. So this is more likely the structure that you're actually talking about. Alright, let's do the second one, and let's see if you guys can do it. So pause the video real quick and see if you can go ahead and do this one. We're talking about CS and N, and then we're talking about what exactly that's going to look like. So in this specific case, we have CS and N, S, C, and N, and then we want to take a look at sulfur and carbon. Both have electronegative values of 2.5. So you can either put the sulfur in the middle or you can put the carbon on the side. Alright, so overall you can notice a couple of things. We have a negative charge here. So go ahead and assign the valence electrons. We know it's 4, 6, and 5. And now how many electrons are assigned for the carbon? The carbon has 1, 2, 3, 4, 2, 4, 1, 2, 3, 4, 5, and 6. Sulfur has 1, 2, 3, and 4. And nitrogen has 1, 2, 3, 4, 5, and 6. Okay, so 6, 4, 6. Alright, so let's go ahead and subtract. So this where it gets a little interesting. It's 4 minus 6 gives us -2. -2 and -1, and again, because we don't have that 0, that's probably not the best way to put that one through. So what we're going to do next is go ahead and put the carbon in the middle. And just as a general tip, carbon generally is going to be in the middle because it actually has that ability to kind of do that. So it's another interesting way of trying that out. So CSN, and now what you need to do is how many valence electrons you have for carbon. So again, 4, 6, and 5. and the electrons are going to be 4, 6, and 6. And if you apply the formal charge now, you're going to end up getting 0, 0, and -1. And again, even though you have a -1 here, it doesn't really matter because you have the zeros for the carbon and zeros for the sulfur. So that's most likely the structure as well. All right, let's do the formal charge number 3. See if you can go ahead and try it yourself. And let's take a look. So draw the Lewis structure for SO4 and check using the formal charges. Count the total number of valence electrons in the polyatomic ion. And so we have SO4 2- here. And if you actually do the math, sulfur here has 6. We have 4 times 6 plus 2. We have 32 total. So if you want to draw the Lewis structure for that, we need to go to step 2. So step 2 is put the least electronegative atom in the center and connect the terminal atoms to it with a single bond. So now we have a single, single, single. You put the bracket in here and it's a 2-. And so now we count how many electrons we have. Now we complete the octets for all the terminal atoms. So 2, 4, 6, 8, 2, 4, 6, 8. 2- charge across. And what you do is you add up all the electrons you have used up and subtract the total electrons from the valence electrons and attach the leftover ones. So basically what we want to do is make sure that we have that 32. So minus 32, which gives us a 0. And then we have to check the formal charges. So if we want to check the formal charges right now, let's go ahead and do that. So oxygen here has 6 minus 7 because it has 2, 4, 6 electrons coming in, and 7. That's -1, -1, -1. So they're all negatives with a 2- charge across. The sulfur in the middle has 6 minus the 4. 1, 2, 3, 4 has a positive 2 formal charge. So if you add up the multiple bonds or eliminate them, you need to eliminate as many formal charges as possible. And the way we can do that is, if you go back to your original one, we can try to see if we can eliminate these right here, the positive 2 charges. So we're going to add in some multiple bonds or change the arrangement of it. So in this case, we're just going to move the double bonds across. And what we're going to do here is 6 minus 6 gives us a 0 if we add in that double bond. And then we add that double bond right there. And then sulfur now has a 0. So as you can see from here, we did not completely eliminate the oxygens because we just can't add any more electrons in here. But we basically were able to get rid of some of these. So the answer here would be a SO4 double bond possible resonance structure here. All right, and that one concludes our quick formal charge problems.